Hello, I welcome you to Noble Lecturio. In particular, I welcome you for this session. We are going to simplify, or we are going to see how best we can easily derive all the equations connected to projectile motion. We've oftentimes seen footballers. I know some of you have played soccer and other games in particular. Wherever a person, say someone is in defense, wherever this person is very busy targeting this ball is always projected at a particular angle if it's going somewhere. If that is done, the ball in space is called a projectile. A projectile, any object that you see moving in space is called a projectile. Now, when a particle is vertically projected upwards, the path or motion it represents, it is particularly kinematics, because it is moving in a straight line. But wherever it is projected at an angle to the horizontal, now we are talking about a parabolic motion. And this parabolic motion is normally put into two sets. One, we talk about the vertical movement with constant acceleration. Two, we are talking about the horizontal distance with uniform velocity. Remember, as it is moving towards at the maximum height and everything, it is also covering some distance horizontally. So, consider a particle. Consider a particle that is projected at an angle, say theta, with initial speed that is u-meters per second. This one represents the y-axis and this one represents the x-axis. At this point, when you see this chalk, as it is moving, before it starts decelerating, it stops momentarily. Where it stops exactly, let's assume is this point. At this point, we talk about maximum height. At this point, this projectile started from here moving and finally rests at point, say point M. When it rests here, the distance it covers from the point of projection, finally, to point M is what they call horizontal range, R. Sometimes. When you look at all this, our major purpose is finding the equations related to projectile motion. If that is the case, your mind should run fast. What do I do before the other? Now, we get velocities first. Then we look at the distances before we go into the equations themselves. We are purposely looking for finding velocities. Now, when you look at this, we have both vertical velocity and horizontal velocity. But when finding velocities at any particular time t, we normally use the first equation of motion, which is v equals u plus at. If you have this horizontally, as this projectile is moving in the horizontal direction, remember, try making this a right angle triangle. When you do, this one becomes velocity that is responsible for the vertical movement, and this is velocity responsible for the horizontal movement. If this is the case, if somebody wants the horizontal velocity, we are talking about Vx now. With respect to this right angle triangle that has been perpetually put here, when you look at it, the distance is seated, the distance is on line on which the angle is seated. In that sense, we talk about a trigonometric ratio that has both the adjacent and the hypotenuse. And that is the cosine that we talk about, because the hypotenuse is u and the adjacent is this, and it's what we are looking for. So you say from cos of theta is equivalent to the adjacent out of the hypotenuse. So we shall have adjacent Vx out of the hypotenuse, which is u in this sense. Finally, we shall have Vx giving us u cos of theta. Remember, wherever we are moving horizontally, we have uniform velocity. If it is uniform velocity, then acceleration is deemed to be 0. If acceleration is 0, going back to this, we shall have Vx shall be the same as, instead of u, we have u cos of theta, because we are looking for the horizontal velocity. So we shall have u cos theta. It would have been plus 80, but remember acceleration is 0. So a, which is 0 times t, you end up getting as 0. That's why we have Vx equals u cos of theta. And this is the horizontal velocity. Now, since you've gotten the horizontal velocity, now you need the vertical velocity. So vertically, we shall have V equals u plus 80 still, just like we did here. But in this sense, we are having a body that we are projecting vertically upwards at an angle. In that sense, it is moving in opposition of gravity. If that is the case, the acceleration becomes negative gravity because it is moving just in opposition of the pole, which is naturally meant to be pulling items downwards. So when you have this, we shall have Vy. Now we're looking at the vertical velocity, which is Vy. In this sense, you see this Vy is directly opposite to this angle, and we have the hypotenuse as well. The only trig ratio that has opposite and hypotenuse within one expression is the sine. So we try looking for sine of theta. So sine theta shall be Vy out of u, which is the hypotenuse. So in this sense, Vy will turn into u sine of theta. If you have this, it implies instead of the u in this equation, the first equation of motion, then the u turns into u sine theta as the vertical component of this projectile. So we shall have, therefore, Vy should be the same as, that is velocity, the vertical axis shall be the same as u sine theta minus dt. Why minus dt? It is because the acceleration turns into negative g in that sense. Remember, vertically we move with a constant acceleration. This is horizontal velocity, and this is the vertical expression for the vertical velocity. After finding velocities, try finding distances. When you find distances alongside velocities, it is going to become fun when you're solving the other equations. Take note of this, because the body may not be so wide. So after this, I'll be rubbing you for this. So be careful as I'm airing out this simple mathematics. So when you have this, we have now finding distances. Horizontally. Now, when we are finding distances, we use the second equation of motion. I'm talking about equations of motion with my mind knowing that you're well aware of these equations. In case you're not, don't worry. Nobody to you is here to solve everything in relation to that, in relation to mathematics, by the way. So don't look at these things and think they are very hard. No, feel free. And I told you one time that with mathematics, it is about a principle or a concept and application. When you have that too, you have math in your hands. Let's proceed. So horizontally, we look at the horizontal distance and use the second equation of motion, that is S equals ut plus a half at squared. But in the horizontal, when we are talking about the horizontal movement, we are talking about from this point to this point, where we have acceleration as 0 because we have uniform velocity. In that sense, we shall have Vx, what I can call x, giving us u, which u in this sense we are talking about u, which u is this now, this one, which we said was u cos of theta. That was the horizontal velocity, if you can remember very well. So instead of ut, you say u cos theta times t. And that one becomes your horizontal distance. Now we're looking at the vertical distance. The way we've done this is the same way you're going to do the vertical. However, for vertical distance, we shall look at this. We shall be very careful with this. So we shall say vertically, this is why, because you are looking at now this distance, this one. We're looking at that. Don't look so hard. Don't have mathematics is about smiling and laughing. Just smile, laugh, and everything moves on. When you have y, it should be the same as u. In this sense, our u is u sine theta, just from here. So we shall have u sine theta times time minus. Why minus? Because remember I told you the g is becoming negative, g is replacing the acceleration, because this particle is opposing the gravitational pull. Why don't you see that? So we shall have minus a half gt squared. If that is the case, so if someone asked, how do I get the vertical distance? Tell this person that the vertical distance is always equal to u sine theta times t, which it is time at any point, so minus a half gt squared. Call that on the fourth. After getting velocities, now you start off. We want to get time taken to attain maximum height. We want to get maximum height itself. We want to get the time from here up to this point. Which time does this particle take from the point of projection to the maximum height? Then you ask yourselves, what about the maximum height age? What is it? Then you ask yourself, after having the maximum height, what about the time this body takes from this point to this point? That's what we call the time of flight. Then after that, think right and say, why did this guy write R? We are looking, then we shall look for range. After looking for range, we shall have to go and look at the equation of trajectory. Because this parabolic movement is always represented by an equation called the equation of trajectory. Did I say trajectory? The equation of trajectory. So, we say time taken to attain maximum height. Maximum height. Time taken to attain maximum height. We are talking about maximum height and we are talking about time. We shall go back and use the first equation of motion that says V equals U plus AT. Since we are talking about maximum height, we are talking about the vertical movement. If that is the case, we shall have Vy shall be the same as U in relation to vertical movement becomes U sine theta minus Gt. Why? Because we are coming back and we are talking about the vertical movement. Using the first equation of motion, but substituting it vertically as in motion. When you have this, remember, at this point, look at this point. That is the point at which, you see, where this chalk turns and starts falling down, where it starts decelerating. At that point, this particle momentarily stops. If it stops, at that sense, we shall say the maximum height, or the maximum height represents zero final velocity. So we shall have V as 0 at that point. So we shall have 0 giving us U sine theta minus dt. Try making it the subject. So you bring this d to this side. Is that really hard? After doing that, divide by t on both sides. Divide by t on both sides so that t remains the subject. So we shall have dt giving us u sine theta. Divide by g, divide by g. So we shall have t is equivalent to u sine theta out of g, and this one is always the expression used for finding time taken to attain the maximum height. Hope it is very clear. I say take note because I'll be rubbing off this side since this board is not so wide to accommodate everything that I'm going to give. We are looking now at maximum height. Maximum height. Now, for maximum height, there are two ways in which you can get maximum height. One is using the third equation of motion. Two is using the second equation of motion as well. It depends on where you feel the compatibility. If it is maximum height using the third equation of motion, v squared equals u squared plus 2as. In this sense, s turns into h. The displacement s turns into h. Then, remember it is maximum height. And at maximum height, we say final velocity is always zero. And at that point, you also remember vertically, u is the same as u sine theta from here. From here, we say vertically, the velocity is u sine theta. If you know all that, then you're ready to go. So we shall have vy squared, which will be a 0, should be the same as u sine theta, that is squared. This one binary from here. Hope it is very clear. After that, we say plus minus 2gh. Minus because it is opposing the gravitational pull. H because h represents the displacement. In this sense, but at maximum height, Vy is equal to 0. So we shall have 2gh giving us u squared sine squared theta. I've brought this one this side since this one is standing for 0. So bring this one this side so you have it positive. 2gh giving you u squared sine. The square is not on the angle, it is on the ratio. Sine squared theta. After having that, so we shall have divided through by 2g on both sides. So we shall have 2g. Why do I need to repeat it? Let me just write h is equivalent to u squared sine squared theta out of 2g. Wherever you asked to find and prove the expression that represents maximum height capital H or maximum height H, that is it, and this is how simple we do it. Just imagine someone is talking, just talk, why do you take math very hard at such distances? Yet these things are as simple as you see them. At this point, after getting the maximum height, now we've gotten this. We've got this time, we've gotten this now. Now, what do we want? We want to find out how long does it take for this particle to move from the point of projection to point M at this point. So in that sense, that time is called time of flight. Time taken by the particle to move from the point of projection to the final point where this projectile was projected or was meant to go. So it's a time of flight. Time of flight. Now look at this. We shall use the second equation of motion that says S equals ut plus a half at squared. In this sense, we shall not have a positive reason, well known that I've said throughout here. We shall have a represented by a g. We shall have now t small, because small t represents half the distance. Now, the capital T will represent a full journey, time taken for a full journey. And remember, this part was moved from this point to this point. So at this point, finally, the displacement will be 0 at this point. So we shall have S, we do it this way. At point M, let us have point M. At point M, S shall be 0. Remember the horizontal distance or the vertical distance, we say this one was y, but this point will be 0. It will be 0. You can say S equals 0, or you can call it y equals 0 at this point. The y value is 0. The y component is 0. So at that very point, t turns into capital T. In that sense, do the substitutions. We shall have 0 is equivalent to, don't forget this u, that it is representing a vertical motion. And we say, whenever you represent a vertical motion, u, that u represents u sine theta from here. Hope you can remember. So it is u sine theta times t, now, non-small t. Then minus I have dt squared. Looking at this makes me wonder why someone can stop from here and not finally get the final answer. Because everything, these are not now projectiles. This is algebra, linear motion. Sorry, linear equations now. That's where we are. So when you have this, you can either factorize out what is common, which is t, or bring this on this side. Do whatever is easier for you. When you look at it, somebody will say it is a half dt squared, giving us u sine theta times t. In that sense, this is a square, and this is t. The t will cancel with the square, with one that is this side, and remain with one to this side. This 2 you see in here is a fraction here. It will multiply this side and becomes 2u sine theta. So this t will cancel with that t. So we shall only have dt giving us 2u sine theta. This is where we are now. Since we need t, say divide by v, say divide by v. So finally, time of flight will be 2u sine theta divided by v. Wherever you are requested to find or derive the expression for finding the time of flight of a projectile, this is the way to go. And when you look at it critically, look at the equation for time taken to attain maximum height. When you look at this and this, they have a certain relation that time of flight is twice time taken to attain maximum height. Just from here. Time taken from here to here is the same as time taken from here to here. However, what the capital time of flight is, you multiply this time by 2, or you add it, and you have the sum to get the time of flight. Now, we are mainly with finding the range and the equation of trajectory. One thing you should remember, in mathematics, if you to use any of the equations and you're not told to derive them, we don't mark written equations for finding particular answers, but the substitution is what matters. So today it is about deriving these equations. The next time we will be having worked up examples using all of them, such that we can digest and understand, particularly and mathematically assimilate whatever we're talking about here. Now, our target is finding the range now. Remember, the range is the horizontal distance this projectile covers from the point of projection to the final place of this projectile. If that is what you're looking for, remember the horizontal distance x is u cos of x. That's what we say, that's horizontal. That's how it is. But remember, as you're talking about the horizontal distance, range is what we need now. When you look at it, we are talking about the horizontal distance. So remember, velocity is uniform. We have uniform velocity, which is u cos theta. That's the horizontal, that's the uniform velocity that we are having horizontally. After having that, just imagine someone asked you, how do we get distance? Equation to find the distance. So, distance in this time will be range, and we shall have velocity, that which velocity is uniform multiplied by time. So we shall have, in this sense, distance equals velocity times time. In this sense, our distance becomes the range that is covered horizontally. Finally, our velocity is uniform, remember. So we shall have u cos of theta times, now here comes the target. We said we have two times. We have the time of flight, and we have time taken to attain maximum height. When we are talking about range, we are talking about total distance covered by this particle. If that is the case, there is no way somebody can use time taken to attain maximum height. We need the time of flight because you're talking about the total distance covered by that projectile. So when you have this, you multiply the time of flight, which is 2u sine theta out of g. 2u sine theta out of g. I repeat, we use time of flight wherever we are substituting for range. Reason, range is the total distance that a projectile, that this particle covers from the point of projection to the final place where it rests. When you look at this, you find out that it becomes 2u squared when you look at this, cos theta sine theta out of g. From your trigonometry, particularly double angle, hope you remember that sine of 2 theta is always the same as 2 sine theta cos theta. Looking at this, then turn your eyes and look at this. There is a 2 which is here. Remember, this is a product. There is sine theta which is here. Then there is cos theta which is here. So substitute for 2 cos theta sine theta with sine 2 theta to make it simpler. So we shall have r giving us u sine u squared sine 2 theta out of g. When you have this expression, then you are in a position to claim and say, I know how to derive an equation that leads us to finding the range of a projectile. Range does not stop there. Range is somehow twisted sometimes. Someone is going to ask you, calculate maximum range. They are going to ask you to find maximum range for this. Yes, you know how to calculate range. What about its maximum? Go back at your trigonometry. Your teacher told you, wherever you have sine of any angle here, the maximum value that you can ever attain for a sine is always positive 1. And the least value that you can ever attain for sine, the minimum, will always be negative 1. Having that in mind, whenever they ask for maximum range, think of making sine 2 theta a maximum value. That's when we talk about maximum range. And it only happens when sine 2 theta equals 1. That's when we talk about it. Maximum range. Maximum range. I say it occurs when sine of 2 theta is equal to what? Is equal to 1. So in this case, you're going to find out that 2 theta is equal to 90 if you look at that. When you look at it, divide by 2, you realize theta is equal to 45 degrees. Somebody may ask you, calculate maximum range and the value of theta with which it occurs. This is how simple you can do it. If this is the case, if it only occurs when sine 2 theta equals to 1, therefore, the range maximum shall always be u squared out of g. Because this one shall always reduce to what? To to 1. That's how we get maximum range. So when the way you get the maximum range would be the very same way someone will get the minimum range if at all at one time has been asked. Remember, the minimum value of sine is always -1. Lastly, for this session, we are looking at the equation of trajectory. The equation of trajectory represents a path through which this particle moves until its final place. The equation of trajectory governs the movement of this parabolic motion. When you have this equation, trajectory. This one is a combination of two motions. You have both the horizontal and vertical motion. Remember, we said the horizontal motion. Horizontally, we had x equals u cos theta times t, if you can possibly remember. And we say vertically, as we are looking for distances, I say vertically, say y was what we referred to as s at one point, because we are using the second equation of motion. But because we are talking about the vertical distance, so we choose y instead of s. Y equals u sine theta t minus a half dt squared. These are the two distances, both horizontal and vertical. When you have the two distances, a combination and the substitution into one of them leads to getting the equation of the trajectory. When you look at the first equation, the horizontal, from, if this is, for example, 1, and this is 2, for this particular case, we shall have from 1, t is equivalent to x out of u cos of theta. If you can name this one not. When you look at this, when you make a t the subject, it will be x divided by u cos of theta. After getting this, substitute it into the vertical movement. Substitute t into the vertical distance. So, substituting for t in equation 2, so we shall have y giving us u sine theta times t, which it is x, divided by u cos theta, minus, hopefully you're moving together, minus a half g into x out of u cos of theta, but square. That's where we are. After having this, look at this. This is u and this is u. So they cancel out. U cancels with the u. Look at a situation where you have sine theta divided by cos theta. Trigonometry, that one becomes tan. Look at this. You have a half g. A half, this 2 becomes makes a fraction here. This becomes x squared divided by u squared cos squared theta. Let me do the writing now from the talking. So we shall have y giving us, this one cancels with this, we have x tan theta. Hope that one is very covered here. This goes with this, sine over cos is tan, and there is x here. This one I'm covered. Then minus give x squared. If this x is squared, if this bracket is opened, the square will come on x divided by 2u squared cos squared theta. That would be that. If that is the case, you remember that 1 over cos is always sec theta. Now, if it is 1 over, if it's sec squared, if we square this one happens. So if it is 1 over cos and it is sec squared, here we have y equals x tan theta minus, look what it is. We have gx squared out of 2u squared times 1 out of cos squared theta. So if this is squared, this one becomes also squared. That's what we have. Hope I'm communicating to every person. Now, when you have this, you finally say y is equivalent to x tan theta minus g x squared, this one, sec squared theta divided by 2u squared, in this sense, 2u squared. If this is the case, are you aware? Anyway, it depends on how somebody can stop there. However, there is a scenario where someone's going to tell you prove, and instead of a sec, they have a term within. Remember that sec squared theta is always 1 plus tan squared theta, so that you express everything here in form of tan. So finally, we say therefore y is equal to x tan theta minus dx squared sec squared theta divided by, sorry, we are substituting for sec and putting its equivalency in tan into 1 plus tan squared theta. The whole of it is out of 2u squared. What you have here is the equation of trajectory. Now, having derived all these equations, the task remains in your hands to understand and mathematically assimilate everything here, such that at any one time, if any of them is asked to be proven or to be derived or to be used anywhere, you can come up with the right thing. However, the other session, we shall have worked up examples using all the equations derived in this session. Thank you so much.